What if the biggest problem in quantum technology turned out to be the solution? Scientists have just discovered a way to purify light, and this breakthrough could push quantum computers and ultra-secure communication closer to reality. Researchers at the University of Iowa uncovered a new method to clean up streams of photons, the tiny particles of light that power photonic quantum systems. These systems rely on single photons moving in a precise, orderly way. But until now, that control has been incredibly difficult to achieve. One major obstacle is something called laser scatter. To produce a photon, scientists shine a laser at an atom, prompting it to release light. The problem is that laser can create extra unwanted photons along the way. These strays act like electrical interference in a circuit, reducing efficiency and reliability. There's also a second issue. In rare cases, an atom doesn't behave perfectly and releases more than one photon at once. That might sound harmless, but in quantum systems, precision is everything. Extra photons disrupt the clean, single-file flow needed for computing and secure communication. Here's where the discovery gets interesting. Graduate researcher Matthew Nelson noticed something unexpected. When atoms emit multiple photons, those photons closely match the color and wave shape of the laser light itself. That similarity makes it possible to tune the system so the unwanted photons and the laser scatter interfere with each other, effectively cancelling themselves out. In other words, the noise becomes the solution. As lead researcher Ravitej Uppu explains, stray laser light, long considered a nuisance, can actually be used as a tool to eliminate multi-photon emissions. It's a theoretical breakthrough that flips a decades-old problem on its head. This matters because single photons are essential for photonic quantum computing. Unlike classical computers that use bits, ones and zeros, quantum computers use qubits, and photons are one of the most promising candidates. A clean, controllable stream of single photons is faster, easier to scale, and far more secure. Think of it like guiding students through a lunch line. Single file is orderly and efficient, a crowd is chaotic. In quantum communication, that orderly photon stream also makes eavesdropping far more difficult. By precisely controlling the angle, shape, and timing of the laser hitting the atom, the researchers believe they can cancel out nearly all unwanted light, leaving behind an exceptionally pure photon stream. If confirmed experimentally, this approach could remove two of the biggest barriers in photonic quantum circuitry, accelerating the development of powerful quantum computers and more secure global communication networks. The next step is turning theory into reality, and the researchers plan to test it soon. Sometimes the future of technology isn't about eliminating noise, it's about learning how to use it.